This is Watch Lead, this is Scott France. We are descending into Phoenix Canyon, currently at a depth of approximately 475 meters. I'd like to give a shout out to Mrs. Spencer's middle school science class, who are apparently tuning in and watching us explore the Phoenix Canyon. This is an area that, to our knowledge, nobody has ever visited before, so this is very exciting.
Bottom in sight, altitude 13 meters, descending.
Along your lines of welcoming the middle school, I know the front row here would like to thank everyone who stopped by to see the ship and see the vehicles in Baltimore for the Star-Spangled Spectacular.
We are in the western North Atlantic. We are approximately 60 miles off of the coast, perhaps 95 miles from Norfolk, Virginia. We are going to be exploring the south wall of the canyon today. What we're hoping to see are some coral communities. There have been groups of scientists who have been developing some predictive models which basically allow them to predict where we may find coral communities based on the shape of the bottom, the topography, the expected geology, the hardness of the bottom, whether there's a lot of sediment or rock, and so on. And so essentially we are going to see how accurate those models are.
So this is Susan Schnur. I'm going to be describing some of the geologic observations as we go down on this dive. And submarine canyons sort of come off the continental shelf, and so they're a major conduit for sediments that are coming down off the shelf. So we do expect to see a lot of sediments. We're hoping that on the steeper walls of these canyons that we'll see some rocks exposed, some older rock layers that may be a little bit more resistant to weathering in the canyons. And again, these hard substrates are also good environments for corals.
Even when we don't see animals all the time, the various pitting and tracks are good evidence that there's a lot of organisms down here. The organisms that are down here are feeding on food that is ultimately derived from surface waters. Basically, the energy comes from the sun, is used by phytoplankton in the water column and various organisms that feed on that phytoplankton. And then the organisms that are in the deep sea all rely on the food that ultimately is drifting down through the water column and either settling on the bottom, where various organisms will essentially pick it out of the mud, or captured as it's drifting to the bottom. A squid that just caught a fish?
It's looking like it.
No,
Wow.
it's a fish that just caught.
Oh, wow.
So fish has
Wow.
got to grab something.
He's got a
a cuttlefish. Is that a
no,
cuttlefish?
he's got a, oh, zoom
in.
hole.
It's
Wow.
octopus, a squid.
Huh.
Permission to zoom more?
Look at
zoom?
that. Yeah, if we can get more zoom on that,
Wow.
that's outstanding. Outstanding.
Wow.
So believe it or not, what you're looking at here are parasitic copepods, and mostly what you're seeing are the eggs that are trailing off of the female.
It's really striking how much life there is here. I mean, we started out on that sandy bottom, not too much going on, potentially lots hiding in the sand.
This is a king crab in the group of the king crabs, maybe in the genus Neolithodes, a little bit hard to tell right now. One of the things that you will notice is that there are only 4 pairs of legs rather than 5 pairs of legs that you would expect to see on decapod crabs. There is indeed a 5th pair of legs. They're just very small, and they're tucked up underneath the back of the carapace, and they're used for cleaning out the gills, and I believe also where the abdomen is folded underneath where the eggs are held.
Even the octopus is covered with sediment. I thought it was just us.
It's gorgeous.
Oh.
Yes, it's walking on its arms. Our final depth, we're leaving the bottom right now, is 1,023 meters. We did get as shallow as 1,003 meters before we came back down here to do the end. So 1,023 meters we leave bottom. Temperature is 4.4 degrees, and we'll see you soon. Thanks everybody for joining us.